Okay.
All right.
Well,
okay.
We're gonna write an OpenRewrite recipe. That's what we're gonna do. We're gonna just write one, and to just a little bit of just repeat this last bit. This is an issue that's out there on the OpenRewrite board, asking if it would be possible to write auto remediation that would unwrap repeatable annotations. So if you remember from pre-Java 8, you were not able originally to add two annotations of the same type to a method or to a class or wherever an annotation is valid. And in Java 8, they introduced the @repeatable annotation that you could in turn put on annotation definitions, and that allowed us to discard these wrapper objects like this or wrapper annotations and just place both of these annotations on the method or the class or whatever it may be. And this is one of these things where in a lot of these libraries that had effectively repeatable annotations, they have gone and added the @repeatable annotation to them, but they can't remove the wrapper because there's so much code out there that's dependent on the wrapper. So, this is our effort here, and the recipe we'll write is to take any repeatable annotation and unwrap it so that it has, get rid of this value mappings and leave it looking like this. And so, like any responsible development, I guess let's start with just a unit test. And I'm going to show you how we write tests for things like this. And so jumping over to the IDE here, we have a class that just implements.
John, I think you need to reshare your screen.
I see.
Yeah, thanks.
Woo! Yeah.
So while you're doing that, hi, everybody.
Guess you missed all that.
That's okay. We got Jonathan Schneider from Modern presenting the OpenRewrite project to us. And basically, it'll take and transform your code base from Java 8 to Java 11, Spring Boot 1 to Spring Boot 2, Quarkus 2 to 3, Migrating 1 to 2. Remember right, something like that. And then also, if you're using Log4j, it'll help you transform to SLF4j. And so Jonathan's going to walk us through taking and how to write our own recipe as well for our own code base. So whatever your code base might be. So very, very exciting. And we also have a door prize link. If you haven't taken a look at your chat yet, please feel free to fill out that survey. Toss your name in the hat to win a door prize. Big thank you to our sponsors, Improving and IntelliJ, JetBrains giveaway IntelliJ Ultimate. And then we got Sonar Hello Tomorrow giving away Sonar Graph, and Headway Structure 101 giving away Headway license. And then Big Cat Subramanian, big thanks to him for giving away a one-year subscription to his Agile Learner website, and then Webucator for a one-class voucher for their learning courses as well. So Jonathan, please take it away.
All right, thanks, Jim. Yeah, but we're gonna get right into, at this point, we're gonna get right into writing the code of one of these recipes, and it's something, a really unique case that I think will highlight some of the different parts of the framework. So let's just get started with writing a test itself, and we're going to start with a class that just implements rewrite test. We'll post the link to this GitHub repository that has all this code afterwards, so you can examine it and poke around and play with it yourself as well afterwards. But what's cool about this rewrite test is we're actually going to write the text of the code, like code samples that we would potentially want to change, right here in the IDE itself, inside the new Java text blocks inside. And so you can we like to use Java 17 for text blocks. You can also use, Kotlin, which has multi-line strings, Groovy, which has multi-line strings, or of course you can just use, single line strings as well with pre-Java 17 if you'd like. But we'll use text blocks here to kind of show that off as well. And let's just start by what's interesting about this is because we've, this is just a little trick, since we put this language annotation on the API, IntelliJ is actually going to help us write the example program inside the test string. Just one of these, like, you know, it's hard to imagine it's even possible. And even more, I can actually go here to an intention action in IntelliJ and say edit Java fragment. And this is wild. So what we're going to do is we're going to say value, and notice how as I write this, the text is showing up above, right? I think I have this one on the clipboard somewhere. This value mappings, this is from the example that we wanted to write. And, you know, I can do the, like, you know, intention actions to import here just in this little editor. And notice it's adding all this up here to the test itself. It looks like value mappings isn't meant to be on a class, so I guess it's supposed to be on a method. So let's like put it down here just on a method named test. Doesn't really matter too much. And yeah, so that looks like it compiles now. And again, it's kind of one of the neat tricks here is that the tests that we write are in strings, but the IDE will actually help you write them. And I like to simplify these things down. So let's just do a star import there, just make it a little easier to read overall. And what we're saying here is this is the code that we're going to start with. Now, this code has uses this library called mapstruct. I actually don't know what mapstruct is. It was just in the issue. Maybe some others have used it, but it's in other words, it's a dependency. It's something that Rewrite has this parser where it's going to parse code, and we need to tell that parser what we mean when we see mapstruct. So here, just like a before each or before all in JUnit, we have this thing called defaults and a spec, and we're going to set this. We're going to set a parser. This is how you construct a Java parser and Rewrite. So pretty easy. And I'm going to say I want to grab something from my runtime class path called mapstruct and build it. And then I want to say that for the sake of this test, I'm trying to test a recipe called find repeatable annotations that we'll jump to right after this. So that's kind of the setup for this test, is that, you know, I have a special parser that knows about mapstruct, and I'm setting the expectation about what the recipe is that I'm going to test here. So far we've any source file. Notice I could define multiple source files here. I could add Java, another one here. You can even define some structure. So I could define a POM XML that has, you know, some dependencies, because some recipes will, you know, influence dependencies as well. I could put this whole thing in a Maven project called test here, and actually, you know, so test that kind of thing as well. And so, and then I could even have this POM have a parent POM. So I mean, you can really just lay out the whole structure of a project that represents the test that you're after. But for our case here today, I think it's sufficient to just do this one file. So right now we've said that this recipe doesn't do anything. By only having this text right here, we're saying that this file won't change. But in fact, what we want to do is find all the usages of repeatable. And so I'm going to copy this, and I'm going to say that this text is going to change. In Rewrite, we have this concept called markers. We'll see in a moment, but markers just allow you to hang a little piece of, like I found something on the AST. And for the sake of tests, we print those out as comments that look like this, that just point out the element that we're finding. And so this just gives us a way of writing actually a very sophisticated search recipe, which is nothing but just locates the thing that we're interested in. And so we're going to want to assert that we find the two value mappings, the actual repeatable annotations. And that's it. That's it for the test. So I think we're done with that. Now we're going to head over here to the recipe code itself, and I filled out a few of the details, but notice that we just have a class. It extends recipe. It has a display name. It has a description. We'll fill this one out in a little bit, but you know, most recipes have a visitor. And because Rewrite is operating on an abstract syntax tree, and abstract syntax trees are usually navigated using the visitor pattern, we're going to implement this visitor that looks for certain kinds of things. Mostly we want to identify repeatable annotations. That's what we're looking for, right? So of course, because they're annotations, I'm going to just say, let's visit annotation. We're going to implement this piece right here. We don't have to do anything else. So rewrite's going to be responsible for navigating the rest of the tree, getting you to any annotations that exist anywhere in the code. And we're just going to be focused on this one piece here where we look for annotations. So I want to say if, this annotation, and notice there's a type on it. So this is the actual type of attribution information the compiler puts on it that we were talking about earlier. So if this annotation is repeatable, then I want to return, I'm going to add this marker. We talked about markers. This is just this invisible construct on the AST that we're turning into a comment like this. I'm going to add a search marker. So I'm going to say annotation.getMarkers.search result. That's a little shortcut. Just put a search result marker on anything. And I'm just returning early because I found the annotation I'm looking for. So I'll just go there. Let's implement this. This is repeatable. So here we've got a Java type, and Java types have a lot of different implementations. We've got type attribution for arrays, for classes, for generic type variables, for methods, for multi-catches, all sorts of different types of things that exist in reality. But we know it's an annotation. And annotations are always fully qualified class names, right? An annotation can't be a primitive. It's a class ultimately. So let's just cast this to a fully qualified, and we have a utility to do this to just kind of get it down to a type that we like. And so if this type, I'm going to add an if statement here that'll become more apparent in a little bit, but for now it's going to seem a little silly. We're going to say if this type that we're looking at is an annotation, which we kind of already know from because we're visiting the annotation here, but you'll see why that's relevant here in a moment. We're going to say if it's an annotation, we can actually look at the annotations. So, to kind of get a sense here, let's open this actual value mapping annotation that we're looking at. This value mapping annotation itself has annotations, and we're looking for this. So, no, that's not visible anywhere here in the code. A human, if I didn't see this value mappings and I just saw one of these, I would have no indication that this is a repeatable annotation. So it's our ability to look up the tree, look through the type attribution information that gets really interesting here. So I'm able to look at the types annotations, even if that code isn't defined in the same project. It's coming from a binary dependency in this case. I'm just going to iterate over all of them. So this is it's like an annotation of annotations, hurdles all the way down, right? And I'll say if type utils dot is of class type, java.lang.annotation.repeatable, then it's a repeatable thing. So that should be it. I hope. Demos are always terrible on the poor soul that decides to do demos, but we're going to run this test here and see what happens. I hope for the best.
So can all this run locally, or does it have to connect to some to an engine somewhere, or?
This is all running locally. Yeah,
wow.
There's no connection to any sort of engine anywhere else. It's just it's just right here. Oh, I see. Let me get rid of this for the time being. We'll come back to this in a moment. And so, actually, I should have left that failure for a moment, but hopefully it worked. Yeah, look at that. So it actually passed that time. So we actually found them. So what's interesting here, and just to kind of highlight some of this, let's just remove 2 of these characters so that the text isn't the same anymore. What we're really doing, this test is going to validate all sorts of things, but one of the things it's going to validate is that this before and this after text is what you say it's going to be. And we've gotten to the point where you can go in the IDE and say, what does it look like? View assert difference. And so this is a Command D, and it's actually going to pop up a side by side that says, oh, I guess I'm missing a couple characters right here, and that's so if the recipe did the wrong thing, it gets really easy to debug the actual thing, get it down to a working state. But I think we're putting it back here and making it work again. So this works and everything's cool. That's really, that's great. And I could ship this recipe as is. This is a working recipe. We do have another concept that I just want to introduce, which is this recipe has a thing called single source applicable test, which is basically a test that sometimes we can define on recipes to early return. Basically just like, I'm not going to find the thing I'm looking for anywhere in this source file. So you might as well just skip it. And that can, when we're operating on 400 million lines of code, this kind of thing can be really nice to make the recipe run really quick, just like really make it scream, right? So the single source applicable test is going to demonstrate here an interesting feature where we're going to visit just the top level AST element. And the top level AST element, so you think when you look at a Java source file, you got the whole file, you got the classes, you got the methods inside the classes, you got the blocks inside the methods, et cetera. You can kind of go all the way down this tree. But we're just going to look at the top level class. And what we have on the top level class is this thing called types in use. And types in use has information about all the types that I find anywhere in this file. So it's a quick, like one-off check I can do up front before I go, on this expedition navigating the whole tree to see whether I'm even going to find one somewhere, and just to make it real quick to operate on. And so here I'm just going to iterate over these types in use, and I'm just going to do the same thing. Really, it is repeatable Java type. Then I'm going to do the exact same thing I just did on the other one, markers.search result. And so with applicable tests, any modification to the tree, including adding a marker, is considered a thumbs up. It's applicable. And so often cases, applicable tests just do this. They just do something. They modify the tree in some way. The modification we make here is thrown away. So it's just kind of a quick test. We throw away whatever modification was made, and then we proceed with the normal recipe. And if I run this again, I hope having added this, applicable test is still going to run. And should be the same result, but we've just made it a lot faster now. For most files that don't have a repeatable annotation on it, it's just going to skip across them and move on to the next file really quickly. So that test still passes, so that's cool. Now, we've just written a search, and I took the search and I uploaded it to the public SAS, and I just ran it across all these Jenkins repositories. And so we can click into these. I was like, I don't even know what kind of repeatable annotations exist. Extend with from JUnit 5 is one of the examples. We could look at HashiCorp Vault plugin. Here's an example of one of these ends. See that end? And we've located all of these, env annotations that we should, in our next recipe here, unwrap. And note, I don't even know about this annotation, right? The recipe didn't mention it. I didn't even know it existed prior to running this. We're strictly relying on the type attribution information that's on that AST to determine whether the types annotations themselves have repeatable on them. So that's really cool, I think. So let's go to the unwrap side of this. And I already wrote this test. It's very similar to the other one, recipe, parser. It's got a before and after. The only difference is that, now rather than just marking it, we're going to take this and actually unwrap it into the two annotations here applied to the method. So and it's just going to demonstrate completely different things than the other one did. So maybe we'll start with this method, which is just given a list of annotations, unwrap any annotations that you find inside of it. So we note that here I could be taking one item and replacing it with, two items instead. So it's this situation where, I want to basically iterate over the list and either keep the annotation or replace it with multiple other ones that are sub-elements of it. So we have these facilities called list utils, and the main purpose of list utils is to avoid creating new list until the very last moment when we know that there's an actual change being made to the list. Because we determine whether a file has changed based on whether or not when we bubble all the way back up the visitor stack, we've got the same reference or not. So the entire AST is immutable. And if we've made any modifications, when we bubble back up to the top, the references won't be the same, and we'll be able to do something. So list utils helps us just really quickly make modifications to lists potentially. And if no modification has changed, return the same instance. And there's various different methods on it, but we're going to use this flat map in this case. And flat map allows us to return either a single element or multiple elements. And we'll just, if it's multiple elements, we'll just like flatten them into the resultant list. So we'll just, implement this thing really. And, so inside of this, I'm going to create a, the potential holder of all the unwrapped annotations that I might encounter further down. Maybe it's never going to have many, so maybe like 3 is a good initial capacity here, just to be really extreme. And note, like I can use visitors, so I'm in a visitor, but I can just create a new one anywhere really. And in this case, because the annotations that I'm unwrapping could be, several levels down potentially, the easiest way of just scooping them all up is to just write another visitor here for a moment, and you'll see that we're going to just visit annotation, and we're going to manually say I want to visit this annotation in the list of things that I'm potentially unwrapping. And I'll say if the unwrapped list at the end of this operation is empty, then just return the original one. There was nothing to do. And if it isn't empty, then return the unwrapped form of it. IntelliJ is helpfully telling me, dummy, it's always empty, but it won't be for long. So here in visit annotation, I'm going to say if, well, first of all, if it's not the actual thing that we're trying to navigate down. And I'm going to use this method from the other one that we just wrote, this other recipe. We already have an is repeatable method, so let's just use that. And so I'll say if this one is repeatable, then I'm going to add it to the list. So there's that. That's it pretty much for the unwrap. I think that's pretty much the implementation. So now let's look at a couple things that can have annotations on them, like method declarations. So I'm going to call super first. It's either fine either way, but this just gives me a variable I can work with. And I'm going to unwrap its annotations and assign this to a variable itself. And I could say m.with leading annotations, and right here. And kind of note that like if there's been no modification here, if this list is the same reference, then calling with on this doesn't make any modification to the method either. So I can always just kind of do this presumptively, like this is only going to change things if there's actually a change hasn't been made here already. So it just makes it real easy to do. But and maybe that's good. We could do the same thing for class declaration, but just to skip ahead here, let's run this and see what happens. And once again, let's hope the demo is kind to me. So close. Notice we did unwrap it, right? We did unwrap it, but we left these extra spaces here because it's essentially still as indented over as it ever was. So I want a facility to basically like just sort of vaguely auto format the thing that I'm like leaving behind after I'm done with this operation. And so we've got a number of different forms, but this is a really interesting use of this form. We have this thing called maybe auto format. And again, we want to make minimally invasive changes. So maybe the code was kind of badly formatted to begin with, and I only want to format this if I've actually made changes. So I'm going to say if the before is not equal to the after, And, I could just maybe auto format on this. And, I could just put the execution context it's asking for up here. Let me rename this. And that should do it. Maybe. Oh, I did the wrong.
Closer. Looks like you're getting closer there.
Closer. Almost got it. Yeah. I need to put, you kind of have to relativize. Like I'm auto formatting like indentation relative to what. And so in visitors, we have this concept called the cursor. And a cursor is just like a stack of all the things I've visited to this point getting here. So I could be inside a method declaration and say, I came from inside of this, 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 all the way up. And there's all sorts of interesting things you can do with cursors we won't talk about today. But let's run this one more time. And that's good. Now, I mean, we are really obsessive about making the minimum change necessary and not having any opinions about the state of the code that we see when we start. So like the thing here is I've just decided to auto format this whole method. But really, I just wanted to deal with just these annotations that I'm potentially unwrapping. So what if I had some like really ugly or beautiful, depending on how you see it? What if I had n equals 1, like in m equals 2, and like I was like writing a haiku here essentially, or something, is in my like, then, I kind of want, intelligence, like, what are you doing, right? I don't even know if these are the same at this point. I'm messing this up so much. Let's just do this. Sure.
One of them's like, yeah.
Yeah, it's going to be something like that. Yeah. And so if I run this right now, because I've just ran maybe auto format on this whole like thing, I would expect that these statements inside this method declaration are going to get formatted as well. And I'm going to have lost my beautiful poem inside of this by virtue of the fact that I've changed these annotations on the outside. And so like, I know this seems extreme, but we really care about this kind of stuff. So there's another form here, which is, stop after. I'm going to say stop after the this last annotation that I find in this list, and just like don't auto format beyond that. Whoops, wrong one.
Yeah, the one thing that like comes to mind is like some teams, like they want to have all of their equals, all of their assignment operators lined up.
Yeah.
So.
Yeah. Yep. Yeah, you never know what you're going to find. And so, yeah, in this sense, because we've instructed the auto formatter to just stop after that like last thing I could potentially care about, then it's going to be okay. And now technically I could be encountering a method declaration that doesn't have any annotation. So I should say, if, is empty, then just return them, or eagerly. So I don't get this like index out of bounds exception here. But that's it, so I hope that gives you kind of a sense of what's possible, with this. We've just kind of written one of these just completely, from nothing. Over here, I uploaded this one and ran it as well. And, not surprisingly, this HashiCorp one we saw earlier, it does in fact take this envs and unwraps it and pulls the envs out of it and sticks it right alongside the other annotations there. So, and, again, this could be really tedious potentially if you had this pattern over and over and over and over and over and over and over again. But that gives a sense of it. I'm happy to kind of like open it up now and just like take questions. I could show other things as well. Actually, I'm going to run one just to show you something outside of Java, which I think is kind of cool, which is like upgrade Maven dependency. And here I could say like group, any artifact, And what we're really proud of is this latest patch. Because this doesn't actually exist, in Maven or Gradle. And it comes from this recognition that something like Jackson often has these deserialization gadget vulnerabilities that, Taffy has been fantastic about going back and, to old versions and patching. And he's really good about, making no breaking changes inside of patch releases, but minor releases are a different story. And if you rev part of the minor release of part of a Jackson dependency, like you're going to break the app pretty much every time. So here we're going to just take this one and just run it on that same, we're just going to pick on Jenkins today. And the idea here would be that, we go find these dependencies and rev them and look for places where the dependency version has been specified by a property and backtrack to the property and update the property instead of the dependency, and like all these things that you would do as, a human working on dependency updates. But we'll kind of let that churn for a little bit. And curious if there's any questions in the meantime. Oh, here we go. I already got some coming through. Yeah, so this one, was on 2.12. So let's just rev it to 2.12.7. This one was on 2.7. So we'll rev this one to 2.7.9. Yeah, you see like this, we identified that Jackson.version was the property being referenced in defining some Jackson dependency. And so we're going to just go update that instead. And, this could cross, the actual dependency could have been in a sub project, and we would have gone and backed up to the parent, found where so just all the work that kind of you would do, manually has been encapsulated into this recipe around updating versions. A lot of other things we could show, but that's just
one question in the chat. Does the execution overwrite the file in place in my repository?
Yeah. So let's maybe talk about, there's a lot of different modes of operation. On docs.openrewrite.org, we have this quick start for Maven and Gradle. And here they'll kind of walk you through how to add the plugin. So you could run any of these recipes we've shown here via build tool plugins as well locally. And we have a different commands. So we have one called rewrite run for Maven, and for Gradle it's rewrite run. And this command, this goal or task or mojo will overwrite the contents on disk. So you would do that, you would review and commit. But there's also a dry run command that that just kind of gives you an idea of what could change, and that doesn't make modifications on disk. And what some folks will do is use a combination. The build tool plugins each have a feature that allows you to, if a recipe would make changes, you can break the build. So this gives you an easy way of then shipping some opinion, could we not use repeatable annotations? I'm tired of seeing this kind of thing. Just add that to a parent POM, add it to a common build configuration. Allow the build to fail if you want. You can introduce a gate there when that happens, and then the developer just has an easy, rewrite run to fix. So there's kind of no excuse to not just fix the thing, right? And you don't have to feel as bad about breaking if you do that kind of thing. Or you can be less aggressive about it and just surface the information and hope they do it. So I think it depends on the culture you're operating in, what's the most efficient means. But that's kind of how that works. Really good question.
What's that site? That's called Rewrite?
OpenRewrite.org. Is that correct, John?
Yeah, to GitHub, to go to, so GitHub is just OpenRewrite/rewrite. And that's just, just here. Inside this org are a bunch of other repositories that do various different kinds of recipes. But this is the kind of core refactoring technology here, and some of the core recipes are here as well. So yeah, I'd love it if you could go check this out. And there's a docs link, just so you have one place to go. There's docs.openrewrite.org is the place where the reference documentation remains. Then, the public form, again, where we're running this is public.modern.io. It's just signing with GitHub. Just and then run the whatever recipes. We keep all the recipes up here as well. And our goal is to run one of the world's largest repositories of pre-parsed and type attributed ASTs in the world. So we want to hand that to security researchers. We want to hand that to academic institutions working on graph neural networks and other automated program repair facilities, and just be the place where we add billions of lines of code to the public knowledge base.
How does this compare to Refaster that is part of Google's error-prone?
Yeah, that's a really good question. Refaster is a technology that that allows you to specify before after templates, and it'll go and make modifications. I worked with those folks a bit while I was at Netflix. Refaster is really clever because it uses annotation processing to scoop up the AST, look for semantic equivalent trees, and replace them. But its cleverness is its downfall as well. So Refaster can only make modifications inside of blocks. Okay. So that example we saw from JN4 to 5 earlier, where we take an annotation on a method, replace it with an assert throws inside, is something that would be always outside of the scope of what Refaster could do. Okay. So we do have a mechanism we didn't show today called Java template. And Java template allows you to, in a string form, build up text of code that you want to insert. And I think logical conclusion of templating, is going to be something like, that's going to ultimately look like this, where you could say, create auto template and define the piece of code you want to insert into something. But for now, Java template, you could find usages of it. Could find it use in I'm not sure if I'm sharing the right screen again here. I always click the wrong thing, I think. Whoops. Oh, my keyboard decided to stop working on me.
No.
Open that. My keyboard's like, I give up. It's been a long day. You've typed on me too much.
No worries. So while you do that, there's another question that came through the chat. Do you have the ability to refactor YAML? We often forget to sort JSON properties, and it's annoying to sort manually.
Yeah, that's a really great question, and we do. We've been building, some of the, for example, Spring is changing application.yaml all the time, changing properties, and so we have YAML automatic refactoring. You'll see some of those here. Core recipes, change key, change property name, merge YAML, coalesce YAML, merge whatever. And then sometimes we build higher level things on top of that. So Kubernetes recipes, GitHub Actions recipes, use the Tamarind distribution, not OpenJDK, et cetera, these things. And actually this kind of model illustrates another point. We talked about markers earlier. We used search markers, but there's all sorts of different kinds of markers. Can you say my IDE? Right now? Okay,
yes.
Great. So there's markers like Java source set that we put on the top of every Java AST element. And Java source set just has information about every type that was on this source set's class path at the time of compilation, whether or not that type is used in the project. So it's think of it like a super bomb, not just like a Cyclone DX bomb, but drilling down to the entire type attribution information about every class that was in every library on the class path at that moment. So recipes can make decisions like, if Guava was there, then do this. If Commons Lang was there, do this. If, and that's one way in which you can craft recipes that do the minimally invasive thing. I don't have to add a dependency in order to fix something in a certain way. But other things that, are on the AST get provenance, the origin path branch, the Java project, the project name, publication, the Java version. So you can contextualize a recipe based on, whether it's Java 7 or whether it's Java 8 or whether it's this or whether it's that. There's just all sorts of these markers. And the one of the most significant, we have an XML AST. So XML.document is the root of this AST, just another AST. But Maven, you saw us making those changes. Maven resolution result is a marker, and Maven resolution result has all of the dependencies, the parentage, all its modules, the resolved dependencies, dependency management sections, like every piece of information, properties, everything we could scoop out of the whole tree. And we just let that sit on the top of an XML document. And that becomes a data source that you can interrogate to then make really interesting changes to the POM XML. So as we go further and further into YAML, imagine the same thing. If I've got Kubernetes YAML, I can put a marker on the top of that YAML document that has all sorts of information about the clusters potentially that it's involved with. You just kind of let your imagination run wild there.
Very good. That's just very encouraging.
That's a good question as well. Thanks for filling in all the gaps on things I forget to mention.
How much could a user such as, somebody who's just watching the presentation, they want to try out OpenRewrite, how much could they accomplish, and at what point do they need to go to use Modernity? What's sort of the inflection point, I guess, for lack of a better better description to.
Yeah, also a great question. I think we're very serious about the core library and every recipe we write being open source. And there's an incentive for us on that. We work with the Spring team on writing recipes. There's 4 developers there on the Spring team writing recipes right now. We have a couple developers in Red Hat writing recipes. The Oracle team and Micronaut team wrote the recipes maybe from 2 to 3. So we really want them to take responsibility for these things. Test containers. There's Edu just made 38 recipes a couple weeks ago to migrate you from one thing to another. So we want to see that happen. You can always run these recipes with the build tool plugins. Where I think the change comes is that most organizations have 20, 30, 200, 400 million lines of code. And so, you could take each repository, clone it, and run the recipe, with the build tool plugin. And for something like JUnit 4 to 5, that may save you a month of work on one repository, but then how do you do it on the other 1,000 repositories? And that's where we're really just trying to help distribute the change.
Okay. So on a massively large scale, this is what you're looking at with Modern versus OpenRewrite.
It can be, and some of the companies we work with are relatively small. So that one I mentioned is only 70 developers, but they've got a lot of code. And so it's, the problem scales with the developers, I think. 70 developers may have 20 million lines of code, 6,000 have 400 million, but it's kind of equally a problem for both audiences.
Okay.
Yeah. Really good question. Thanks for that.
Yeah, my pleasure. Any questions from y'all?
But this is converting Java 7 into Java 11?
Yeah, so that's one of the recipes they have. You can convert from Java 8 to Java 11. Any luck with Java 17 yet? Since it's
Yeah, I think there's not too many differences between 11 and 17 that are relevant.
Right. Yeah.
We do have a parser for it that we'll keep adding more types to, which is a whole interesting story in its own right. But Spring 5 to 6 is going to be rebased on 17, and Spring Boot 3 is going to require Java 17. And so that's why I mentioned there's 4 developers now working on the Spring team on writing recipes, and they're very conscious of this, like what differences are there between 11 and 17, and also the core framework changes that they're making.
That's great.
Which are, I think, even more substantial than what they did in 1 to 2, unfortunately. So,
Do you happen to have something that translates code to other languages? For example, Java to Python or Lambdas. That's something.
Yeah, it's a really interesting question. So kind of typically outside the scope of what we're interested in, But there's a related point here, which is that languages that tend to exist on what we call grammar islands, that is that they're self-similar languages that surprisingly share the same AST model. And so I'll list a few of those. Along with Java on the same island is Groovy, not too surprising there. Kotlin, that one looks a little different, but still on the same island. The TypeScript, Python, C#, Golang, all are on the same island. So they actually all share the same AST model underneath the covers. And what's different then is, I know, really surprising result, but what's different then is how that AST is printed out as text. And so interestingly, we can take like a Groovy source file and just, for the most part, just print it as Java. It just kind of works, you know, and except that there's going to be like a couple small differences. So Groovy has G strings, you know, in addition to strings, you know, like, so these kind of things could be smoothed over. And then it's API changes at that level. It's replace this API with that API. Those are all itemizable and doable, but you know, it's a question of whether it's worth the effort or not. I think, like anything, there's just so many things we could do. What do we spend our time on?
One question from the chat. Would I want to use this to, for example, wrap calls to a third-party library in my code, or would that be taking a bazooka to kill the roaches?
I've seen something like that. We work with an insurance company that has an internal date library that they don't want folks to use the regular Java date library. And it's for a business reason. They want to be able to take their whole policy administration system and shift it forward or backwards in time in test in order to be able to test policy expiration and renewals and so forth. But you can imagine being the sort of like senior engineer there. That's like, you know, one phrase we've heard is like, I feel like I'm going around telling my kids to pick up their socks all the time, right? Like, you know, you get a new crop of developers in, they don't know this pattern, and they're going to, you know, understandably use the regular Java date library. So, you know, that senior engineer could be like, okay, this is the pattern I want to see. I'm going to encapsulate this in a recipe, and I'm going to run it in perpetuity. So that like this pattern, it's basically like self-teaching then, you know, the pattern just gets fixed. So I think there's legitimate uses, but
even then, just on a smaller scale, or you know, less than, I guess, intensive scale, moving from java.date to java into the new Java time libraries.
Yeah,
like that.
That's exactly right. I think that had been mentioned earlier, and it goes the other direction too, which is or similar, which is like, you know, Guava, how much pain has that caused us? You know, the break-in changes in every other release of Guava. But a lot of the Guava API surface area is covered by the JDK right now. So we have a whole series of recipes around just replace usages of Guava with the equivalent JDK call, if it's possible. And then you could have a recipe which says remove dependency, if not using anything in it, right? Just remove dependency. So it's you can just run that one, and you gradually winnow down the API surface area to the point where you can eliminate problem libraries like that in the organization.
Oh, that's great. Very cool.
Yeah. These are all really great questions. Good audience.
Good. I'm glad.
So if you, from let's say JUnit 4 to JUnit 5 migration, let's say you're on an older version of Gradle, would I need to basically uplift the version of Gradle in my app to do the migration, or can I just say, let's run this off of some source code because I think you're on Gradle 7 and it would do everything automatically, then we can go ahead and test it on our own? How would that work?
The Gradle plugin is backported back to Gradle 4, I believe. We could probably go back to 3 and 2.
No, I don't need to go further.
Kill me. But I don't think we want to. So Gradle 4 is about as far back as we go right now. But yeah, there's a lot of reflection hackery that we do to make that the case. But
okay, do we have?
I think the project as a whole really has this position that like there's no, we understand where everyone's at, right? It's not like we're not coming in and saying like, I wish you were here, do this. No, it's like, it's very practical. Like we understand where we're at. Let's meet you where you are and like get you where you want to be. That's the main goal.
Okay.
Yeah. So there was a follow-up question, sorry.
Yeah. Anything ongoing, let's say Spring to Spring Boot?
Yeah, there's related things. There is, for one customer, they have Spring XML and want to turn that into annotation-driven configuration, which then allows them to rev the version of Spring and then, of course, move some of that to boot as well. We have even more extreme efforts underway around like moving WebLogic EJBs to Spring Beans. So that kind of stuff is in the realm of possibility. And is, kind of like there's plans and active work on some of those things. So with many of these things, it's going to be, there's a diminishing return at some point. Like, Spring is such an expansive ecosystem that you could just do nothing but that for a long time. But, one reason we like to see people in the OpenRewrite Slack and, working on Git is just like, tell us what's important to you right now. That's what we'll add to the top of the list. There's actually, and this gives me an opportunity to show something else, which I think is interesting. Another search, which is a bit surprising maybe, but find usages of deprecated methods.
Yeah.
So this is kind of similar to the one that we just wrote where we're looking at annotations on, on types that we're looking at. And so let's just look for all deprecated usages of Spring. And I think it's kind of funny.
In the comments, then you have it as an annotation type as well.
Yeah, that's true. That's true. I think in this case, I didn't even consider that. We're only looking in the annotation, but the AST does have comments as well, and we have the Javadoc AST. The Javadoc AST is part of the Java AST, so we even have the deprecated annotation as a separate visitable thing, independently of. So it's definitely doable. So it's funny to just do this on Spring itself. Like, let's just look at deprecated usages of Spring in Spring. Because there's so many repositories, they have a hard time keeping up with their own deprecations sometimes. It's kind of funny. Yeah, we're loading up some of these. And I think we use stuff like this as a way of prioritizing our action. And maybe one of the other, kind of like reasons why people put their code in Maven, because internally when they're considering making, big changes and sweeping changes internally, this kind of helps them understand the scope of the problem they're about to tackle by doing things like this. So yeah, you can see get scheduler properties was deprecated. So sometime this liveness probe, it's going to break if they don't make this modification. And you kind of see patterns emerge from that.
We have a couple more questions in the chat. One is, can these tools in the catalog be run on our local repositories?
Yeah, and that's the Maven and Gradle plugins, really. You can just apply that Maven and Gradle plugin and just run rewrite run locally and see the change. I think that's where most people start.
So, and then the next question, to search recipes as a personal user for free, I assume we have to log into the Modern catalog. Is that correct?
For the build tools locally, no. I mean, there's no interaction there. If you want to browse around in Modern, it's just GitHub auth is all it is. There's no separate account set up or anything. It's just GitHub auth. And part of the reason we're doing that is because it's really not like for an information collection reason. It's for when you have this commit button up here and you take an action and I commit this result, it's going to be committed on my behalf. I'm going to be the author on this commit when I do it. And Modern is going to show up as a co-author. And in fact, when we look at this screen over here and we're looking at these, I could run recipes on stuff I don't have read access to. I'm just going to see this. When I click in, Modern will actually check whether I have read access to this repository before showing me this. So it kind of aligns permissions to whatever the permissions on the underlying BCS are. Notice we have Bitbucket here as well. We have running a Bitbucket, but we'll hook up GitLab here soon, and you can kind of hook up any number of BCSs to that thing.
One interesting case that occurred to me was if you want to use, say, the Graalvm native image, would you be able to basically scan the AST and identify types that basically need to be listed in the configuration files in order for the native execution engine to basically skip over those? I can't remember what the config file name was, but I worked with that a little bit.
Absolutely.
Okay, good.
Absolutely. I think that's a perfect recipe. So it's very easy to synthesize whole new files actually or delete files or move them or whatever. So like it's just another kind of recipe we didn't show how to write today. But yeah, I think that's a perfect case. I would do it too. We're actually going to wind up probably doing that one ourselves because as we add Python and TypeScript here in the next several months, we're lucky we started on Java because of Gradle. Because you saw when we wrote that recipe, we wrote it in Java, right? But I was writing a Java recipe in Java. And the experience we intend to deliver with Python and TypeScript is you can write the Python recipe in Python if you wish. You can write the TypeScript recipe in TypeScript, and we'll generate the the kind of like type definitions. But then we'll be able to leverage Gradle on the platform. We've already tested this out a bit, so that TypeScript written recipe can run on the same infrastructure. Yeah. So I'm really excited about that. Gradle is going to be the thing that gives us that polyglot recipe authorship experience.
Yeah, I can imagine. Yeah, I mean, I guess like for me though, I mean, I remember trying to make an existing app code base native, and so we could have higher compute density, and we didn't end up using it, but the experience of doing it was very valuable. But it's I compile it, that I it processed it, run, and then would slam into another type. Like, oh, okay, got to add that to the class, to the exceptions list of don't ignore the specific class, please. So if OpenRewrite can help identify all the types that need to be put into that catalog, that would save weeks of effort, I think.
Yeah, I can imagine. I'll mention that to Graham too. We know him fairly well, and him and his team wrote the recipes for Micronaut already, so they're already familiar with the framework. That would be an interesting thing since they manage Gradle as well. It'd be interesting for them to go.
Okay, nice. Very good.
First party from Oracle.
Yeah, that'll be beautiful. There's a mechanism where I think they can do some work for you to help you kind of get started, but I don't think it's soup to nuts kind of situation. So
that sounds right.
Cool. That's very exciting.
Yeah. Any other thoughts from anybody? Again, really appreciate the discussion. Some groups are really quiet. This is a really active one. It's good.
By the way, thank you. This is good. Has your open source code in GitHub been through any security scans, things like that, in case we're asked, so we can say, hey, it's been through this scanner, that scanner?
Yeah. Because we package the platform, Modern platform, and ship it, or we do single tenant SaaS, so we stand up in a completely isolated environment for each customer. We're subject to SOC 2 auditing ourselves. So we have to prove to our auditor that we scan and close critical vulnerabilities within 24 hours in the open source as well, and lesser vulnerabilities within 7 days. So that's part of our commitment. That's part of our SOC 2 report, and then that's audited regularly for ourselves.
Question from the chat. Could you use this to translate between languages, or is it just Java focused?
Yeah, it's there's a different form of a question that came up earlier. There are multiple language models. YAML. We're writing COBOL right now, believe it or not, because that matters. Again, not opinionated about what exists in the environment. Java, we have Groovy already. XML, JSON, Terraform, HCL. Those sort of things are in existence already. But adding C#, Python, and TypeScript by the end of this year, and we're contractually obligated to do so. So we'll have to figure out some way of getting them done. Translating between is kind of like we said earlier, like a lot of languages share the same grammar island. So it's theoretically possible. Like on a syntax level, it wouldn't be hard, but then you would have to make the API, changes as well. And it's just how much effort you put in. And perhaps in a narrow enough domain, it's worth doing. One thing I'll say about this though is the Groovy visitor extends from the Java visitor. The Kotlin visitor extends from the Java visitor. And so, as the Gradle team started looking at writing recipes themselves for Gradle API changes, how they're always breaking things in Gradle from one version to another. Most of the recipes they write are with Java visitor, even though no Gradle file is written in Java. They're always written in Groovy or Kotlin. So a Java recipe automatically works on Groovy and Kotlin. So if you do a change method named Java recipe, it's going to just work on those other two. That's really, I feel like, an interesting result, because you can kind of like write once. The JUnit 4 to 5 recipe we wrote would work on Groovy and Kotlin and Java all the same. We don't have to write 3 different recipes.
Question from the chat. Any plans to add translators between web frameworks such as Angular, React, maybe Vue, or others? I know they're
yeah.
Like Angular is a full-fledged framework, whereas React is a library. Sure. So it's kind of comes from different directions. And Vue kind of sits in the middle, from what I understand. But I mean, so would something like that be possible? Is that too much?
Like Angular to React sounds like too much, but maybe I think so, probably. I think the general way to view this is this. I mean, because there's always different forms of this question, is what parts of development are creative activities and what part are less creative activities. And if you could go to basically, like, you could write it out as like an algorithm, do this, do this, do this, do this, do this, you can do it. It's a program, it's literally a program. And so some things, like, I would say my intuition would be, I wouldn't try to write Angular to React, because that feels like a lot of creative activity. Those are have very different state models, and they're just different fundamentally. But then I'll turn around and tell you in the next breath that we're doing EJB to Spring. That may seem very similar, but the EJB to Spring case has a fewer series of steps. Really, it is very kind of algorithmic in the way you transform one into another, at least in the general case. So it depends, I think another thing I won't do, I don't think, although ask me in 2 years, is I don't think I'm going to try to take a COBOL program and automatically rewrite it in Java. I just think that there's a creative activity involved in that too, and that we got it, and that's what we want to do. I like the art of development. That's what I got passionate about. That's what I want to do. I don't want to like convert JUnit 4 to 5. That's not fun.
Yeah, I think that there have been several attempts at COBOL to Java translators. Don't know how well they've really taken off, but they pop up on, say, InfoQ. I know I've seen one at least there. That,
yeah. I think you wind up with basically the same problem, just in another language. So it really is worth the creative activity it takes to do that. I think in most cases.
I remember the article, the author said, yeah, it's going to look exactly like your COBOL program, but just in Java instead. So it's.
Yeah. Yeah, that's about right. Let's see.
Is there anything else you can share about your roadmap? I know you mentioned TypeScript is one. I know some companies say, look, we're not going to share anything about our roadmap at all.
Oh, no. No, I think, happy to. It's TypeScript, Python, .NET, or C# specifically are the things that, I think we have to be committed to here in the relatively near term. Kotlin as well. Completing Kotlin gives us, kind of 100% dependency management coverage in the Java ecosystem. And, that's been a long objective of mine. But but I think that's the main thing. And I think along the way, I mean, adding, littler DSLs, aren't necessarily that hard. You know, SQL I could see coming in at some point, you know, those kinds of things. Yeah, there's a question about migrating Gradle to Maven or the other way around. And I think Gradle itself has a Maven to Gradle bootstrapping mechanism that's not really well advertised internally. But yeah, that one feels like a, you know, a large ecosystem to conquer, but potentially doable.
What about DSL version migration, kind of automated migration for folks who are using, you know, DSLs inside their organization or something like that? You know, they publish their DSLs and they end up, you know, catching on there in wide use. You know, for example, I haven't been in situation myself, but there may be places where that is indeed the case. You know, so could you write I'm assuming you could write a migration recipe for that?
I think you could. It would look something like this. I mean, really, a lot of the simpler languages that we have, so like the YAML, the XML, I would say HTML wasn't as simple as I hoped it would be, but are actually built off of ANTLR driven AST. So if you have a ANTLR grammar, then there's a pretty, you know, a logical connection to you having a rewrite AST implementation that could perform migrations on top of that grammar. I think as we went through code, so when we went through Java, there's 39 AST model elements in the Java language. When we went to do COBOL, there's over 600. So it was like, whew, you know, the effort level kind of went up a little bit, and we started adding more facilities around, you know, generating the boilerplate needed to, you know, go from an ANTLR grammar to a fully fledged AST to make that, to accelerate that. I would see that go through its paces a couple more times, and we'll probably, you know, have like a toolkit around taking an arbitrary ANTLR grammar and getting an AST more quickly out of it. But see what happens in the next several months there.
What about Clojure? I know that it has some adoption, but not a significant amount. But where it is used, they like to use it a lot. You know?
Yeah. I'll be surprised if we wind up adding that one in the end, because it's esoteric enough that. But yeah, certainly possible. But yeah, feels like it's just enough on the fringe that it's not super likely.
What about Scala? Any thoughts there on that one?
Also a bit on the fringe. I mean, it's definitely less so than Clojure. No plan on Scala right now. And it's just, you know, we try to be very priority driven towards what folks have asked for. I haven't actually had a request for either. Although I used to be, I think Kevin's here, maybe not I used to be like really a zealot about Scala years ago. Not surprisingly. Anybody that's enough of a language geek probably was at some point, but yeah, I think I don't see a lot of use at this point. Okay.
It's the joke that comes to mind. I was at a conference with Java group leaders, and Martin Derberg says he tells a story about, we're using Scala and we're using all of the features. It's like,
yeah.
It's like, okay, good luck upgrading.
Yeah. I think I stopped about, you know, the like encountering Twitter's algebra, you know, abstract algebra in Scala or something like that. And they're like, yeah, we use this everywhere. And I'm like, I don't know if you need that for, but yeah, I understand. I think it did its job to like influence Kotlin's later development. I think that's probably it's about the trajectory it's on.
Got a question coming in chat here too. Tight. So, is there a Slack channel to help us write recipes?
Yes. And that is, you know, just that if you go to docs.openrewrite.org, there's a join us on Slack button here. If you go to the main OpenRewrite thing, I think there's a Slack here as well. We're actually experimenting with Discord too, because we hear that's what the cool young kids are on. But no cool young kids have yet joined us. Maybe because we're writing a COBOL AST, I don't know. Yeah, if we get that Python AST out, we'll start seeing people show up on Discord. I don't know what the correspondence is between these two things. Reminds me of kind of a funny story doing this. So, again, I started this at Netflix years ago, and there it really emerged because of a reason that they had this freedom and responsibility culture, which means central teams couldn't impose any constraints on what product engineers did whatsoever. So there's 2 of us on engineering tools, and there's 700 engineers, and we're trying to get them to move off of a logging library that we had deprecated 6 years earlier, and still like 5 million references to it. And so just like we spent a lot of time, a surprisingly long amount of time, actually trying to build reports in ways that would put them in front of people to get them to move. So it would be, we colorized Jenkins output and like emojis and colors and stuff like that, and like made sure that was the first thing they see whenever they look at the build log, like, please do this, put things, put posters up. We automatically created videos that scorned people. We did like all sorts of things, and like this, it did not result in any action. And at the end of the day, you get a Netflix engineer coming into work and they say, I've got better things to do with my day than like replace one logging statement with another. So they just won't do it. And enough times going from team to team, I would say, what would it take for you to move? And they say like, well, if you do it for me. I kept hearing variations on that. And at some point it was like sunk in, like, I think we need to take that literally. We need to find some way of doing this for them, or it's just not going to happen. And that's kind of where this was born.
Yeah, that was the same situation at Google with error prone. I read an article in Communications JCM where they said basically they found that the only way that they could affect change was to get in the developer's way, and say, okay, look, you have a bug here. You're not going to be able to compile your source, so it's part of the compiler. It's a compiler plugin, and as a result, they can't compile the code if there's a known bug in their code.
I see. And that's interesting, right? Because that's Google's way. Google specifically has that culture where they are much more impositional. They're top down like that. They will say, I'm going to break your bill and you're not going to get it. But then you get Netflix, freedom and responsibility. I could not put a tool like that in the way of a developer. So then it's interesting. How do you get them to move? And it's a slightly different tweak. It's give them the facility to do it automatically, then they'll do it. But even then, you get the like eager early adopters that do it, the kind of like a little bit further behind. And then you have the 3% that just simply won't ever do it, no matter how easy you make it. And that was always interesting because once you get down to that 3%, then I can at least, I've got, a problem. I can go communicate with somebody. And so I started doing that, okay, hey, can I just come to your desk and we're going to run this together? Okay, sure. Go over to their desk. And I started finding, and this is always a risky thing to say in a large group, but I started finding this strange correlation between people the 3% that wouldn't take change and people that would use a trackball mouse. And so, I'm not very good at a trackball. So like if I was going around visiting for a day, I would just carry a mouse with me everywhere. And you show up at somebody's desk and, carrying a mouse and they'd be like, how did you know? It's like, you're one of them, like I know you're one of them. But that's, I see you're recording this. That's great. But yeah, no, it's funny, the little things you see.
Yeah, that's great. Yeah, I guess some of the bugs that come to mind that, like, say, error-prone would catch is you're missing a %s in your printf. Kind of you can't necessarily do that change for them. Perhaps I mean I suppose maybe you could, but I don't know. It's a lot of these things that are bugs that it might be ambiguous as to what the correct value should be in there. Maybe where that might make sense, but.
And a little story about refaster and error prone. I mentioned earlier it's got that limit that it can only operate inside of a block, and that was it's a key limitation. It's super clever. That limitation. I before starting this company, kind of had like a Google offer to work on this team and or start this company, you know, it's kind of either, you know, risky, less risky sort of thing. And you know, but going through that interview process, they said, you know, they'd given up on Refaster and given up on the idea of automatic remediation because they felt like data had proven to them that they couldn't make the significant changes that they wanted to make. And really because of that limitation in Refaster's ability to write inside of a block. And so Google had convinced themselves that this problem was unsolvable. And therefore they should spend their effort instead on developing new cognitive complexity scoring algorithms and things of that sort to, again, report. So they really went hard back to the reporting side of the equation as far as their tooling team is concerned, which is a shame.
It's a longer loop. It's a longer cycle to go and actually fix the issues as a result.
Yeah. So it's, I think that's why you see, you know, Refaster has been, you know, kind of mothballed and hasn't been developed on for years now. It's just been, they convinced themselves that there wasn't enough capability to really invest in it any further. But you know, a slightly different approach, you know, results in a completely different view on the world, I think, here, which is where we're at.
Absolutely.
Yeah. But, cool.
Great. Any other questions? Anybody? Right.
All right. Well, thank you very much for having me. Appreciate it.
Typing something here. Just a second. Let's see.
Oh, yeah, sure. Yeah.
Thank you, by the way. Greatly appreciate this. Was great.
This is great. Very, very exciting.
Very good. Yeah. Thank you. Yeah. Always happy to come help. Appreciate it.
Cool. I'll get this posted on YouTube here in just a few minutes. Thanks so much, everybody. And next month I'll be giving a talk on a tool that I created. It's nowhere near as sophisticated as OpenRewrite, but it's called Refactor First. If you want to take a look at it now, you can go to refactorfirst.org and it'll point you to my GitHub repository. It'll help you to figure out where you can best spend your time if you have God classes. So you can start picking those apart, migrating to microservices, stuff like that. So yeah, have fun. And again, thank you so much, Jonathan. This has been absolutely a pleasure. This is really, really exciting stuff.
Likewise. Thank you.
Next. Thanks so much.
Yep.
Take care.
Bye.
Bye.
We talk about Refactor first during our ice flavor.